Question 11.99 asks us to complete the following table where we have some acids and conjugate bases, and we're asked to find the conjugate base for an acid and the acid for a conjugate base. So you might remember that an acid is a proton donor, so a proton donor, and a base is a proton acceptor. And that's the Bronsted-Lowry definition of an acid and a base. Okay, so let me see if I can fix that. There we go. All right, so if we take a look at HI, so HI could represent either hydrogen iodide or hydroiodic acid. So hydrogen iodide, that would be if it's a gas, and hydroiodic acid is when you put it in an aqueous solution and you'd have HIAQ, so aqueous. Anyhow, so if we think about hydroiodic acid, so if it's a proton donor, so if it gives up H+, so remember, if I draw my Lewis structure, I have HI. So if it gives up H+, that means the two electrons in that bond are going to go over onto the iodine, and I end up with iodide. So the conjugate base would be I-, and if you want to draw the Lewis structure, you can put in all of the valence electrons. If I take a look at chloride, so chloride, Cl-, so if chloride is a conjugate base, then if I add a proton to it, so if I add H+ to it, I would get HCl. So HCl is hydrogen chloride. When it's a gas and when it's an aqueous solution, it's hydrochloric acid. So we have HCl. The next one, NH4, so this is called ammonium. So ammonium, I'll write that in. So ammonium is one of the polyatomic ions you should know. And ammonium, if it loses H+, well, it's already got a positive charge. So if it has a charge of +1 and it loses +1, when it gives up that proton, I get NH3, which is going to have no charge. So it's going to be neutral. And this molecule is called ammonia. And in the last one, I have HS-. So again, HS-, this is a conjugate base. If it takes on H+, so if I take -1, which is the charge of my HS, and I add +1, I'll get H2S. So now I have two H's and my S. And so it's going to be a neutral molecule. Anyhow, I hope you find this useful in determining conjugate bases and acids from their conjugate bases.